Alright guys, welcome back, and we're looking at cumulative frequency curve, and this time around we're going to be looking at a specific example. So first thing we want to do is look at the example here and the table that we're given. Now part A says complete the table above. Now here we have 1, 2, 3, 4 classes, and these classes represent information on weight in kilograms and frequency here. Now we have cumulative frequency on the right hand side of the table, and these are the cells or this is a column that we need to complete the table. Now remember, with cumulative frequency, right, what we have to do is start with the same value that is here and then add this to this. So 8 plus 15 is 23, 23 plus 40 is 43, and 43 and 7 is 50. Now what is the significance of this 50 right here? This 50 represents the total frequency. Remember, cumulative frequency is what we call a run on total. Okay, so cumulative frequency is a run on total, right? So the 50 would represent the sum of the frequencies. So 8 and 15 is 23, 23 and 20 is 43, and 7 is 50. Okay, so the sum of the frequency is actually 50. That is the significance of this value. And based on the first crash course video that you watched, this should represent the highest point of the curve, and it should represent that point on the vertical axis or the y-axis. That's the significance of this guy. It says that's the height of the curve, and that's what you have to remember. All right, so this part here has been completed. Now this says using a scale of 1 centimeter to represent 5 kilograms on the x-axis and a scale of 1 centimeter to represent 10 packages on the y-axis, draw a cumulative frequency curve to represent the data. Now before I can go ahead and do that, what I have to do is establish the points at which I'm going to plot against each other to get this curve, because you have to plot points to get this curve. And I'm just making you know that I'm going to be doing this as a rough sketch first before we do it on graph sheet, so that I don't burn out too much time on the phone and create another storage issue that I had on Saturday. Okay, so what we're going to do here is determine the points that we're going to plot against. Now what we need to do is establish what we call the class boundaries for these classes. So for this one, it would be 0.5. Remember, we take 0.5 here and then add it here to 10.5, and this one 10.5 to 20.5, this one 20.5 to 30.5, this one 30.5 to 40.5. Good. All right, now we have our class boundaries here. So these are the class boundaries for the weight classes in kilograms, and we have the cumulative frequency. Now it is this column that is going to be plotted against that, right? And more so, just pointing out specifically what we're actually going to be using so it stands out. We're going to be plotting the upper class boundaries against the cumulative frequency. Now that's what we're going to do, but there's something very important that has to come up. So basically, based on this, I'm going to be plotting 8 to 10.5. I'm going to be plotting 23 against 20.5. I'm going to be plotting 43 against 30.5, and I'm going to be plotting 50 against 40.5. So I have 1, 2, 3, 4, but there's another one that most students tend to mess up, and they have to pay attention. Now these values here are going to be on the vertical axis, and these values here are going to be on the x-axis. So we're going to locate these values on the x-axis, but we have to remember that the curve must touch the horizontal axis. So what we're going to do is, we know that 50 packages or 50 of whatever items these are, right? Let's just say that these are the weights of packages that were weighed. So it now there were 50 packages that were weighed, right? the information in the question would tell us that. All right, I'm just interested in you being able to calculate, you being able to construct the cumulative frequency curve. So what you have to note is that 50 packages, for example, would weigh from 1 to 40 kilograms. How many would weigh less than 1 kilogram? And that answer would be none. So none would map up against what? And that's where this guy comes in right here. Right here. This guy here that most persons tend to forget. That is going to map with 0.5. And it is this point, I'm going to put an asterisk here, that we get the curve to touch the horizontal axis. And you're going to see what I mean when we get to that. All right. So these are what we're going to be using to actually do this part of the question in terms of plotting this graph. All right. But instead of doing on graph sheet first, I'm just going to do a rough sketch of it so you understand what exactly is happening. So I need everybody to understand that these are the points that we're going to be working with. So let me just slide this to the right here. And what I'm going to do here, I'm just going to take the sheet of paper and just emphasize again the plotting points. So let me just emphasize the plotting points before we proceed. Plotting points. All right. So we're going to plot 0 with 0.5. And remember, this is the cumulative frequency CF. And these are the class boundaries. Okay. So 0 is going to map to 0.5 based on what we discussed here. 8 is going to map to 10.5. 23 is going to map, we're going to plot that with 20.5. 43 is going to be plotted with 30.5. And 50 is going to be plotted with 40.5. So cumulative frequency, class boundaries. And this is going to be on the vertical axis, right? Also known as the y-axis. And this is going to be on the horizontal axis, also known as the x-axis. All right, so that's what we're going to be using to plot to get our curve. All right, so I'm just going to move this out of the way for now, and I'm going to come here. All right, so this is what we're going to be using. So right away, guys, right away, all right, right away, this vertical axis here, we're doing a rough sketch. This vertical axis here is going to be cumulative frequency. So I'm just going to put cumulative frequency, right? And this is going to represent the packages that are being weighed. So this really represents number of packages, okay? So let's say that there are packages being weighed. So this is the cumulative frequency axis, and down here is going to be weight in kilograms. So remember, the classes are weight, all right? So we're going to be identifying the values using the scale that they ask us for. So this is what we have so far, and again, we're going to be plotting these values against each other to get this cumulative frequency curve, which has a characteristics S shape. All right, so the next thing we need to know is look at the scale and then number each axis based on the scale. So it says here that using a scale of 1 centimeter to represent 5 kilograms on the x-axis. So using a scale of 1 centimeter to represent 5 kilograms on the x-axis. So for every 1 centimeter, you're going up by 5 kilograms. So let's take a look at that. Obviously, we're starting here with 0. And of course, this represents 1 centimeter. Very, very simple. So for every 1 centimeter, we're going up by 5 kilograms. So 5, 10, 15, 20, 25, 30, 35, 40, and 50. Right? Now, let's look at what it says about numbering on the vertical axis or the y-axis. Now, it says here and a scale of 1 centimeter to represent 10 packages on the y-axis. So a scale of 1 centimeter to represent 10 packages on the y-axis. So for every 1 centimeter, we're going up by 10 packages. So again, this represents 1 centimeter. There's always 4 small strokes in between. So again, this 0 also serves a dual function. It is a 0 for this axis and it's a 0 going up for that axis. Instead of putting 2 zeros, you just put 1, because this can start this axis and that can start that axis as well. Right? So for every 1 centimeter, we're going up by 10 packages. 10, 20, 30, 40, 50. And remember, we pointed out that the 50 here, this is different. They're just numbering here. Remember, this deals with weight. But this 50 refers to the total number of packages, because that would be the sum of the frequency. And remember, I said in the crash course video that you'd never pass this value. So even though I have another stroke here to put 60, I'm not going to, because I know I'm not going to pass this height in terms of the height of the cumulative frequency curve. So I'm going to stop here. I'm not going to go any further. Okay? Now, all we have to do is plot our points. It's as simple as that. So, before we do that, we have to locate these class boundaries, these values here, and that's where you can't make any mistake. You have to know exactly where 0.5, and remember, this is on the x-axis. So I'm going to have to find 0.5, 10.5, 20.5, 30.5, 40.5, etc. So let's look at this now. So the first thing I need to find is 0.5. Now if this is 0 and this is 1, 2, 3, etc., then obviously 0.5 must be between 0 and 1, because this is 0, 1, 2, 3, 4, 5. So that would be 0.5 right there. So I'm just going to make a note that that is 0.5. And let me just bring it across here so we can easily number. So 0.5 would be there. The next one is 10.5. 10.5, so 10.5 would be between 10 and 11. So this is 10, 11, 12, 13, 14, 15. So 10.5 would be right there. So I'm just going to make a note that that is 10.5. 20.5 is the next one. That will be between 20 and 21. So that's 20.5. And next one is 30.5. That would be between 30 and 31. So it would be here. That would be 30.5. You have to find these things accurately on your graph sheet. And the next one is, last one is 40.5, which would be between 40 and 41. Sorry, this would be 45. Correction. So 35, 40, 45. So that shouldn't have been 50. So I'm just making that correction here. So make a note of that, please. So let's go again. 0, 5, 10, 15, 20, 25, 30, 35, 40, 45. Good. So that should not have been 50. That should have been 45. So I'm just making that note. All right. And then 40 would be between 40 and 41. So this would be 40.5. So now we have the class boundaries located on the x-axis, and quite frankly, we're ready to go now in terms of plotting. So let's look back at this quickly. So we are to plot 0 with 0.5. So 0, right, for the cumulative frequency, so remember 0 is the cumulative frequency, so that would be here. So 0 to 0.5, so that is right there. So I've located that. The next one is 8 to 10.5. So find 8 on the cumulative frequency axis, which is the vertical axis. So if this is 0 and this is 10, I'm going up by 2, which is different from down here. So this would be 0, 2, 4, 6, 8. So this would be 8, and I'm mapping that up with 10.5, which is right here. So I've located that point, right? So I have this out of the way and that out of the way. The next one is finding 23 to map with 20.5. So 23 would be 20, 22, 24. 23 would be between 22 and 24. That's 23. I'm mapping that up with 20.5. I'm apologizing for seeming to go a little fast. It's just that I'm trying to beat the time with the video and the storage space. So I'm apologizing for that. All right, it's already 15 minutes. Next thing, we've done this, is mapping 43 with 30.5. Remember, this column here is cumulative frequency on the vertical axis. So I have to find 43 and then map it up with 30.5. So 43, 40, 42, 44. So 43 would be between 42 and 44, and that is to be mapped up. So if you're on a graph sheet, you'll be easily going across with the lines that are already on the graph sheet. So I'm mapping that up with 30.5. So remember, this is a rough sketch. So that would be about there. And the last one now is 50, which is the top of the cumulative frequency curve, is going to map up with 40.5, which is the last one here. So I'm carrying this across, and I'm mapping it up with 40.5, which should be round about here. As I said before, this is a rough sketch. And what is required of me to do is this characteristics S shape going through 1, 2, 3, 4, 5. And if you look at it, it has that rough shape that we had with the crash course video. So you just do a nice smooth curve. And notice now that I'm coming from the x-axis, so my curve is touching the x-axis. And you have to have you must not use a ruler, free-handed, just like I'm doing. All right, just like that. And you can clearly see here that that kind of has the characteristics S shape, and that's the cumulative frequency curve. Now I'm going to stop the video here because it's already 16 minutes and I don't want to have that storage issue. So what I'm going to do here is create another video that's going to be a continuation from this in terms of answering the rest of the questions. So I'm up to this point, and what I'm going to be doing when I come back is actually part C. So pause the video, replay it as many times as you wish, right? Again, I'm apologizing for seeming to go fast, but I don't have any storage space on the phone, and neither is my memory slot working for me to put in a memory card. So apologizing again, but you can always replay the video, all right? So I'm going to stop it and then continue with the next video. So I hope you found this video insightful, and I'll see you on the next video.